September 15th, 1943. Over the skies of Schweinfurt, Luftwaffe ace Captain Friedrich Zimmermann witnessed something that would shatter every assumption German high command held about American industrial capability. What he saw that morning wasn't just aircraft. It was the manifestation of an industrial machine so vast and efficient that it would render Germany's entire war strategy obsolete. September 15, 1943, 11:47 hours. Schweinfurt Ball Bearing Works, Bavaria. Captain Friedrich Zimmermann of Jagdgeschwader 11 climbed through 22,000 feet in his Messerschmitt Bf 109 G6, expecting to encounter the usual formation of 30 to 40 American B-17 flying fortresses. What emerged from the morning haze instead would fundamentally alter his understanding of American war production. The sky darkened with aircraft, not the modest formations German pilots had grown accustomed to intercepting, but an aerial armada of unprecedented scale. Zimmermann's radio crackled with disbelief from his squadron mates. "Mein Gott, there are hundreds of them!" The 8th Air Force had launched Operation Double Strike with 376 B-17 flying fortresses, each aircraft representing something the German war machine could no longer comprehend: disposable abundance. These weren't precious, irreplaceable assets carefully husbanded like German aircraft. They were products of an industrial system that could manufacture complexity at a scale that defied European understanding. Zimmermann engaged the lead formation, his 20mm cannons finding their mark on a B-17's starboard wing. In previous encounters, damaging an American bomber meant watching it limp away, crew desperately fighting to return their expensive aircraft to base. This time, the bomber simply continued formation flying, its crew apparently unconcerned about damage that would have grounded a German aircraft for weeks. But what stunned Zimmermann wasn't the individual aircraft's resilience. It was the mathematical impossibility of their numbers. German intelligence had calculated American production capabilities based on European industrial models. They had estimated maximum monthly B-17 production at perhaps 50 aircraft. The formation attacking Schweinfurt represented nearly 8 times that estimate in a single mission. As Zimmermann's squadron engaged the bombers, something unprecedented occurred. The Americans didn't attempt evasive maneuvers to preserve their aircraft. Instead, they maintained formation, treating each B-17 as an expendable component in a larger strategic calculation. German pilots trained to preserve their irreplaceable fighters watched the American crews accept losses that would have paralyzed the Luftwaffe. Radio intercepts later decoded revealed American bomber crews discussing replacement aircraft with casual confidence. "If we lose this bird, they'll have another one waiting at base tomorrow." This wasn't bravado. It was the voice of an industrial system so productive that individual aircraft had become tactical consumables rather than strategic assets. Zimmermann's after-action report to Luftwaffe High Command would contain observations that contradicted every assumption about American capabilities. The Americans weren't just producing aircraft. They were producing them at rates that transformed the fundamental mathematics of aerial warfare. What followed wasn't just a tactical surprise, but an industrial revelation that would force Germany to confront the true scale of American manufacturing might.
The shock Zimmermann experienced over Schweinfurt had its origins in fundamental miscalculations that began long before the first American bomber appeared over German skies. When Germany declared war on the United States in December 1941, the Luftwaffe planners had based their strategic assessments on European industrial models that bore no resemblance to American manufacturing reality. Reichsmarshal Hermann Göring's intelligence staff had analyzed American aircraft production using German methodologies. In their calculations, aircraft manufacturing remained a craft-based industry requiring months of skilled labor per unit. They estimated that American factories, lacking Germany's precision engineering tradition, could produce perhaps 2,000 military aircraft annually across all types. These estimates formed the backbone of German strategic planning. The miscalculation stemmed from fundamental differences in industrial philosophy. German aircraft production emphasized individual quality and engineering excellence. Each Messerschmitt or Focke-Wulf represented hundreds of hours of skilled craftsmanship. Tolerances were measured in fractions of millimeters. Components were hand-fitted by master mechanics whose training spanned years. American industry operated on entirely different principles that German planners couldn't comprehend. Henry Ford's assembly line techniques, refined over decades of automobile production, had been adapted for aircraft manufacturing with revolutionary results. Where German factories built aircraft, American factories built aircraft building systems. The numbers emerging from American production lines defied German understanding. By 1942, consolidated aircraft facilities in San Diego were completing one B-24 Liberator every 100 minutes. North American Aviation's Inglewood plant was producing P-51 Mustangs at rates that German intelligence dismissed as propaganda. Boeing's Seattle facilities were turning out B-17s with clockwork regularity that seemed impossible to European observers. German aircraft designer Willy Messerschmitt had visited American factories in 1938 during a technical exchange program. His reports to the Reich Air Ministry described production methods he characterized as crude but functional. He noted American reliance on interchangeable parts and semi-skilled workers, contrasting this with German emphasis on craftsmanship and precision. His conclusion? American methods could produce quantity, but not the quality necessary for military aviation. This assessment proved catastrophically wrong. American engineers had solved the quality problem through standardization and quality control systems that eliminated human variability. Statistical process control, developed by Walter Schiehardt at Bell Laboratories, ensured consistent quality regardless of individual worker skill. Mass production techniques produced aircraft that were not only functionally equivalent to German designs, but could be manufactured at scales that transformed them from strategic assets into tactical tools. The German war economy, designed for short, decisive conflicts, couldn't adapt to American production realities. While German factories struggled to increase monthly output from dozens to hundreds of aircraft, American plants were scaling from hundreds to thousands. The industrial base that had produced 20 million automobiles in the 1930s was converting that capacity to military production with devastating efficiency. By late 1942, German pilots were reporting encounters with American aircraft bearing factory-fresh paint and manufacturing dates within weeks of combat deployment. This contradicted every German assumption about transatlantic logistics and production timelines. The Americans weren't just building aircraft, they were building them faster than Germany could destroy them. Intelligence reports reaching Luftwaffe headquarters painted an increasingly grim picture. American aircraft production wasn't approaching its peak, it was accelerating. The industrial mobilization that would ultimately produce over 300,000 military aircraft during the war was still gathering momentum. German strategic planning, based on European production models, had failed to account for an industrial system that could treat complex military equipment as mass-produced commodities.
The Industrial Revolution that would stun German pilots had begun in Detroit's automobile factories during the 1930s. What emerged wasn't just increased production, it was a complete reimagining of how complex machinery could be manufactured. American engineers had developed what they called the Arsenal of Democracy, a production system that would transform aircraft from handcrafted machines into mass-produced weapons. The breakthrough came through revolutionary manufacturing techniques pioneered by companies like Willow Run, Ford's massive bomber plant. Stretching over 3.5 million square feet, the facility employed 42,000 workers operating in 3 shifts around the clock. The plant's assembly line moved at precisely calculated speeds, with each B-24 Liberator advancing through 3,000 separate operations performed by workers trained for specific tasks requiring no traditional aircraft experience. American engineers had solved the complexity problem through modular design and standardization. Rather than building complete aircraft, factories produced interchangeable subassemblies. Wings manufactured in California could be mated to fuselages built in Kansas and engines produced in Connecticut. This distributed production system created redundancy that German planners couldn't comprehend. Destroying one factory barely affected overall output. The technical specifications revealed the revolutionary nature of American methods. Consolidated Aircraft's B-24 production line could complete one bomber every 63 minutes at peak efficiency. Each aircraft contained 1.2 million parts manufactured by over 18,000 subcontractors across the United States. Quality control systems ensured each component met precise specifications regardless of production location. Statistical process control eliminated the variability that plagued traditional manufacturing. American factories employed armies of inspectors using gauges and measurement tools to verify each component. Rejected parts were immediately recycled or scrapped, maintaining consistent quality while achieving unprecedented production rates. This systematic approach to quality control was foreign to German manufacturing philosophy. The arsenal of democracy extended beyond individual factories to encompass entire industry ecosystems. Detroit's automotive infrastructure provided trained workers, precision tooling, and supply chain management systems. Steel mills in Pittsburgh, aluminum smelters in the Pacific Northwest, and electronics manufacturers in the Northeast all contributed to a coordinated production network spanning the continent. American engineers had also revolutionized training methods. Rather than requiring years of apprenticeship, workers learned specific tasks through intensive programs lasting weeks. Training films, standardized procedures, and simplified tooling allowed housewives and farmers to perform operations previously requiring master craftsmen. This democratization of manufacturing skills multiplied available workforce exponentially. The most stunning innovation was production flexibility. American factories could switch from civilian to military production with modifications requiring days rather than years. Automobile plants became tank factories, appliance manufacturers produced aircraft instruments, and toy companies manufactured precision components. This adaptability created production capacity that could expand faster than German forces could destroy it. By 1943, American aircraft production had achieved rates that German intelligence dismissed as impossible propaganda. Monthly output exceeded 9,000 military aircraft of all types, with production still accelerating. Each B-17 Flying Fortress represented not just an individual weapon, but a symbol of industrial capacity that could replace losses faster than Germany could inflict them. The psychological impact on German leadership was profound. Luftwaffe commanders realized they weren't fighting American pilots, they were fighting American factories. Every aircraft shot down would be replaced by multiple new ones. The mathematics of attrition had fundamentally shifted in America's favor through industrial innovation that transformed warfare itself. The first true demonstration of American production superiority occurred during the 8th Air Force's systematic bombing campaign against German industrial targets throughout 1943. What German defenders witnessed wasn't just tactical air power, it was the manifestation of an industrial system that could sustain losses and maintain operational tempo at unprecedented scales. Operation Point Blank, launched in June 1943, deployed bomber formations that grew larger with each mission despite mounting losses. German fighter pilots like Hauptmann Walter Krupinski reported shooting down multiple B-17s during single engagements, only to face even larger formations days later. The mathematics of attrition that had favored defenders throughout military history was being reversed by American production capacity. The Schweinfurt-Regensburg missions of August and October 1943 demonstrated this new reality with brutal clarity. During the first mission, German fighters destroyed 60 American bombers out of 376 deployed. Traditional military logic suggested such losses would require months to replace. Instead, the 8th Air Force returned with 291 bombers for the second Schweinfurt raid just 11 weeks later, despite ongoing operations elsewhere. German pilot Herbert Rollwagen documented the psychological impact in his combat diary. "We destroy their aircraft, but they return in greater numbers. Each victory feels meaningless when tomorrow brings more enemies than yesterday." This sentiment reflected growing awareness among Luftwaffe personnel that they were fighting an opponent with functionally unlimited aircraft replacement capability. Combat records reveal the systematic nature of American aircraft deployment. B-17 and B-24 bomber groups received replacement aircraft with factory delivery dates, often within days of combat missions. Fresh aircraft arrived with updated equipment, improved armor, and enhanced defensive armament, suggesting production lines that continuously incorporated battlefield lessons without interrupting output. The tactical implications were revolutionary. American bomber crews adopted aggressive tactics that would have been impossible with irreplaceable aircraft. Formation flying prioritized mission completion over individual aircraft survival. Damaged bombers continued to target rather than aborting missions to preserve expensive equipment. This tactical philosophy reflected confidence in unlimited aircraft availability. German intelligence efforts to understand American production yielded increasingly alarming reports. Reconnaissance photographs of American aircraft factories showed production lines that dwarfed German facilities. Aerial surveys of airfields in England revealed hundreds of bombers in various stages of preparation, with new aircraft arriving faster than operational units could absorb them. Captured American aircrew provided testimony that contradicted German assumptions about pilot training. Rather than precious assets requiring years of development, American pilots described training programs producing thousands of aircrew monthly. The United States was training pilots faster than Germany could train fighter pilots to shoot them down. The industrial evidence was undeniable by late 1943. American aircraft production had reached 85,000 units annually, compared to Germany's maximum of 25,000. This 3-to-1 production advantage was compounded by American manufacturing quality that equaled or exceeded German standards. The technological gap German leadership had assumed would protect them was disappearing beneath avalanches of mass-produced American aircraft. Combat effectiveness studies conducted by Luftwaffe tactical staff revealed disturbing trends. German fighter pilots were achieving victory ratios comparable to earlier periods, but overall bomber losses were decreasing due to sheer numerical superiority. American formations could absorb previously devastating losses and continue missions, rendering traditional defensive tactics ineffective. By December 1943, German air defense commanders recognized they faced an unprecedented challenge. American air power wasn't just a military force, it was an industrial phenomenon that could overwhelm defenders through sustained production rather than tactical superiority. The arsenal of democracy had transformed aerial warfare from a contest of skill to a contest of manufacturing capacity.
The psychological transformation of German military leadership began with individual pilot reports but rapidly escalated into systematic demoralization that affected strategic decision-making at the highest levels. What started as tactical surprise evolved into existential crisis as German commanders grappled with an opponent whose industrial capacity rendered traditional military calculations meaningless. Luftwaffe ace Adolf Galland, commanding fighter operations, documented the psychological evolution in his post-mission reports. Early assessments focused on tactical adjustments to counter American formations. By late 1943, his reports revealed growing desperation as he requested aircraft numbers that German production could never provide. "We need 3,000 fighters immediately," he wrote, "but our factories can provide perhaps 300 monthly." The psychological burden on German pilots intensified as they realized their tactical victories were strategically meaningless. Oberleutnant Franz Stigler, who would later become famous for escorting a damaged B-17 to safety, described the crushing reality. "Every American bomber we destroyed was replaced by 3 more. We were fighting mathematics, not men." German aircraft designers faced an even more profound psychological crisis. Engineers who had spent careers perfecting aircraft through meticulous craftsmanship discovered their methods were obsolete. Willy Messerschmitt's design teams could produce superior individual aircraft, but American factories could produce adequate aircraft in overwhelming quantities. Excellence had become less valuable than abundance. Intelligence reports reaching Adolf Hitler's headquarters painted an increasingly grim psychological picture. German high command had based their entire war strategy on assumptions of American industrial weakness. Confronting evidence of overwhelming production superiority forced a complete reevaluation of Germany's strategic position. The psychological impact extended beyond military operations into civilian morale. German workers in aircraft factories experienced unique psychological pressures as they struggled to match impossible production targets. Despite working extended shifts and employing slave labor, German facilities could barely maintain output while American factories increased production monthly. Factory supervisors reported declining morale as workers realized their maximum efforts were insufficient. The broader German population began experiencing psychological effects as American bomber formations appeared with increasing frequency and size. Citizens who had been assured of Luftwaffe superiority watched helplessly as hundreds of enemy aircraft passed overhead virtually unopposed. The visual evidence of American industrial might undermined confidence in ultimate German victory. Captured German documents revealed strategic discussions acknowledging psychological defeat in aircraft production. Planning documents from late 1943 showed German leadership calculating minimum production rates needed to maintain air defense. Their conclusions were stark. Even if German production doubled immediately, it would remain insufficient to counter American output increases. The psychological impact on Allied personnel was equally significant, but opposite in nature. American aircrew gained confidence from knowledge that their aircraft losses could be replaced indefinitely. This psychological advantage translated into tactical aggression that multiplied the effectiveness of American industrial output. Crews flew missions with confidence that institutional support was unlimited. German prisoner interrogations revealed the profound psychological impact on facing an industrial opponent. Captured pilots described feeling overwhelmed not by American tactical superiority, but by the certainty of unlimited American resources. Traditional military concepts of strategic victory through tactical success had become meaningless against an opponent who could absorb any losses and continue operations. The cumulative psychological effect reached beyond military operations into German strategic thinking. Leadership documents from 1944 show planning based on assumptions that American production could not be meaningfully reduced through military action. This psychological acceptance of industrial inferiority affected every subsequent strategic decision, from defensive priorities to resource allocation. By 1944, the psychological transformation was complete. German military leadership had evolved from confidence in tactical superiority to resignation about industrial inadequacy. The stunning reality of American aircraft production had accomplished what no military victory could achieve: the psychological defeat of an enemy's strategic confidence before the physical defeat became inevitable. The industrial demonstration that stunned German pilots at Schweinfurt established principles that would reshape global military strategy for generations. What began as a tactical surprise evolved into a fundamental transformation of how nations approach warfare, industrial planning, and technological competition in the modern era.
The immediate legacy appeared in post-war military doctrine across all major powers. The Soviet Union's massive aircraft production programs of the 1950s directly copied American mass production techniques observed during wartime cooperation. Soviet planners had witnessed American industrial capacity firsthand and structured their Cold War military production accordingly. The emphasis shifted permanently from individual equipment quality to overwhelming numerical superiority through industrial capacity. NATO strategic planning incorporated lessons learned from American wartime production scaling. Military planners recognized that future conflicts would be won by nations capable of rapidly converting civilian industrial capacity to military production. This understanding influenced everything from alliance structures to domestic industrial policy throughout the Cold War period. The transformation extended beyond military applications into civilian industrial development. Post-war automotive, electronics, and aerospace industries worldwide adopted mass production techniques pioneered in American aircraft factories. The statistical process control methods that enabled consistent quality at massive scale became standard practice across manufacturing sectors globally. Modern military procurement reflects the fundamental lesson German pilots learned over Schweinfurt: quantity has a quality all its own. Contemporary defense strategies emphasize rapid production capacity over individual platform superiority. The F-16 Fighting Falcon's success stemmed partly from its design for mass production rather than individual performance optimization, echoing wartime American philosophy. The psychological legacy proved equally significant. Military leadership worldwide internalized the understanding that industrial capacity determines strategic outcomes in prolonged conflicts. This recognition influenced Cold War arms races, where production capability became as important as individual weapon performance. The Soviet Union's emphasis on quantitative superiority directly reflected lessons learned from observing American wartime production. Economic development strategies in emerging nations consistently reference the American wartime model of rapid industrialization. Countries from South Korea to China have studied and adapted the techniques that enabled American aircraft production to expand from thousands to hundreds of thousands of units annually. The playbook for rapid industrialization was written in American aircraft factories between 1941 and 1945. Contemporary aerospace manufacturing still employs organizational structures developed during wartime aircraft production. Boeing's modern assembly lines trace direct lineage to techniques pioneered at wartime facilities. Supply chain management, quality control systems, and workforce training methods remain fundamentally similar to those that stunned German observers 80 decades ago. The technological legacy extends into modern conflicts where industrial capacity continues determining outcomes. Ukraine's ability to maintain military operations depends heavily on Western industrial support, echoing the relationship between American production and Allied military effectiveness during World War II. The fundamental equation remains unchanged. Sustained military operations require sustainable industrial support. Military historians recognize the American aircraft production surge as a decisive factor that shortened World War II and reduced overall casualties. The industrial capacity that stunned German pilots saved millions of lives by accelerating Allied victory through overwhelming material superiority rather than prolonged attrition warfare. The ultimate legacy lies in the transformation of warfare itself from a contest of military skill to a competition of industrial capacity. The German pilots who fled from formations they couldn't hope to defeat witnessed the birth of modern industrial warfare, where victory belongs not necessarily to the brave or skilled, but to those with superior production capabilities. Today, the principles that stunned German pilots over Schweinfurt remain relevant as nations compete in aerospace, technology, and manufacturing. The lesson endures. In modern conflicts, industrial might, multiplied by technological innovation, equals strategic victory, regardless of traditional military virtues on the opposing side.